In this problem, we have two parts. In part A, we are going to sketch the graph of a function on -1, 2 that has an absolute maximum but no local maximum. In part B, we sketch the graph of a function on the same interval -1, 2 that has a local maximum but no absolute maximum. So let's start with part A. We have to define or draw a function whose domain is -1, 2. We have this sketch here. We have then the domain is from -1 to 1. Sorry, from -1 to 2. All points there has image, and we can see this decreasing, simply decreasing function. And those for this function, the key thing is that it is always decreasing, and for that reason there are no local maximum. So we have this part fulfilled. There is no local maximum, and we have an absolute maximum because that happens here at that point. That is, the absolute maximum is the image of -1. But there is no local maximum because this value here, which is the absolute maximum, occurs at the left endpoint, so it cannot be considered a local maximum. And inside of the interval -1, 2, there is no local maximum at all. So this is an example. This could be also a line, but you can draw a curve like this, having always the decreasing behavior in the whole interval -1, 2. And with that, we have the result we want. But the part B is a little more interesting because we have to do the inverse thing. That is, same domain, but now the function has a local maximum and no absolute minimum. The key thing to notice is in both parts, there's no mention about continuity of the function or what happened with the minimum or local minimum. So we have sketched this solution for part B, and you can see that to have a local maximum inside the interval, like this point here, but no absolute maximum, there's got to be a behavior like this. This point here, that should be the highest value in the graph, the highest point, it is not included in the graph, but the image of -1 is put over here. So we have created a discontinuity that has the effect of the function not having an absolute maximum value on the interval. That is because we had when we don't include this point, means that the function can have always a greater value all the time, where we are very close to -1 from the right, but it never reaches that highest point. And that forces us to create a jump discontinuity like this. But we have a local maximum at this point here. And look that the graph has to have at least two other local minimum in this case, but there is no mention about that in the statement, so that's no problem. And because there was no mention about continuity of the function, we could do that to create the effect of not having an absolute maximum for the function. But if we include the continuity, it will be another problem. Maybe we cannot have solution in that case. But the key thing in this part B is to think about a discontinuity that creates the effect. So we have then a function here with absolute maximum but no local maximum. And in part B, a function with one local maximum, no absolute maximum. And that's a solution to the given problem.